In this problem, we are being asked to give the products following all that sequence of reaction starting from acetylene. So let's get started on that. So first, what do we see here? Acetylene, and we're treating that with Lindlar's hydrogen in Lindlar's catalyst. So that reaction, number one, is a hydrogenation, but it's partial, and it's going to give us ethane. So after reaction one, hydrogen in Lindlar. Here, what we want really is to use a Poisson catalyst, not to get the alkane, just to get an alkene. But Lindlar typically is used when we want to get a specific stereochemistry. If we have more carbons, we can get the cis alkene. But here we just have two carbons, so what we get is alkene, ethylene. So now, second reaction, we're adding HBr. So what that is, and let's write it like that, just to remember the mechanism. This is a hydrogenation, and it goes Markovnikov, the regiochemistry. But in this case, all of the two carbons are identical, so there is no such a thing as one being more substitute than the other. So it's very simple. We just go pi electrons acting as a base. And what we're going to get at the end here is ethyl bromide. So you see here that we have two carbons to the chain. Now the problem says that we're going to combine that with the product of reaction 3. And reaction 3 says acetylene and sodium amide. So what you get with sodium amide, let me just erase that. We're going to combine those later. So acetylene and sodium amide, you're going to be making this anion. So and now the problem says that you want to combine these two. So clearly what we have is now an SN2 reaction, which we have done previously. So you will have those electrons attacking, doing an SN2 attack here. And the final product here, you have two carbons here, and you will have two more. So 1, 2, and 3, and 2 more. Then it says, following the sequence, that we do hydrogenation again with Lindlar catalyst. So here what you will do again, that's Poisson catalyst, you will get an alkene. So after reaction 4, again, let's do hydrogen, Lindlar catalyst. We will get here, again, if we had a substituent here, we would have the cis alkene, but here we don't. So we're only going to get, say, butene, one butene. And then it says perform reaction 5 is HBr. So it is another addition of HBr, so hydrogenation. This time, we have to pay attention where we put the hydrogen. Previously, we had no substitution at ethylene here, but now we have substitution here. Here you have H and H and H. So this reaction goes with Markovnikov regioselectivity. So we will have pi electrons. We will attack here to get this hydrogen, and the hydrogen will be attached to the least substituted carbon. So meaning here where there's more hydrogens, so we will have that. So that way we make, remember, either mechanism. When we do that, we will create this carbon cation, and later on, the final product will have a bromine in this position. So the final product of the sequence of reactions that we have there is 2-bromo-butane. And it was fairly simple in the sense that we just had a couple of reactions to remember. Lindlar hydrogenation that is used to form alkenes from alkynes. when we use that catalyst, and then we use hydrohalogenation. In one case, we didn't have a substitution on the alkane, so not as important to say the regioselectivity. But in the second case, we had another alkene where we had a carbon less substituted than the other. So here we need to pay attention of the regioselectivity of this reaction. And it goes Markovnikov.